all of you to the next session of Exploring Physics. In the last class, we completed our first lesson called Matter. In today's class, we will start our second lesson called Physical Quantities and Measurement. In this second lesson called Physical Quantities and Measurement, we will learn about these topics. Measuring the density of an irregular solid, measuring the density of a liquid. We will see how the floating and sinking of objects are occurring, and we will also learn how the density of substance varies in 3 states of matter. Before we move on to the topic, we will first enrich ourselves with the vocabularies in this lesson. Do you see here? A tea is being poured to the cup using a teapot, right? The liquid is flowing out through a small tube. Can you notice it? Yes. How do we call it? We call that small tube a spout. What is meant by spout? A tube or lip projecting from a container through which liquid can be poured. See this picture. When an object is being immersed into the water, what happens? The water level rises. Why? It's because the object is taking over the place of water, right? That is, the object displaces the water. So, what is the meaning of displace? Displace means take over the place, position or role of. Here, the object is taking over the place of what? Water. So, we should say that the object displaces the equal volume of water. What is this? This is called pendulum clock. The pendulum is moving back and forth in a regular rhythm, right? Can you observe it? Yes. How do we denote this? We denote this as oscillate. The pendulum is oscillating back and forth, right? See, oscillate means move or swing back and forth in a regular rhythm. Shall we move on to the activity to begin our learning? We will see an interesting activity to start our learning. First of all, we have to take a glass and pour some water, add some color into it to differentiate, right? Then we are adding the syrup. What you are observing, the syrup is going into the bottom. Why? It's because the density of the syrup is greater than the water. That's why it's going into the bottom. Then we are adding some more water. Then we are adding the oil. What you are observing? The oil is not mixing. The 3 liquids are not mixing. The oil stays on the top. When we are adding the 3 different liquids, they are not mixing but they are forming the 3 different layers. How is it possible? Why they are not mixing? What is the reason? It's because of the density. The density of the syrup is greater than the other 2 liquids. That's why it's going into the bottom. That we know. The density of the oil is very lesser than the density of the other 2 liquids. That's why it stays on top. So we have witnessed how the density is playing its role in our daily life. Right? So it is very important for us to learn deeply about density. We should learn how to measure the density, right? We are going to deal with this factor called density. What is the definition of density? Density is equal to mass divided by volume. We have already learnt it in our 7th standard, right? So recall it. density is equal to what? Mass divided by volume. We have also studied the units of the density. What will be the units of density? Guess. The mass is kilogram. SI unit of mass is kilogram. So kilogram per SI unit of volume. What it is? It is meter cube. So the SI unit of density is kilogram per meter cube. What will be the CGS unit of density? How the CGS unit should be represented? It should be represented in gram and centimeter, right? So CGS unit of mass is gram divided by CGS unit of volume is centimeter cube. We can write it as CC because it's coming as centimeter cube, right? So we can write it as CC. So we know the SI unit and the CGS unit of density. Now so we know that SI unit of density is kilogram per meter cube and CGS unit of density is gram per centimeter cube. We have studied the relation between these two. What is that? It is 1000 kilogram per meter cube is equal to 1 gram per centimeter cube. This is very important for you to know, so keep this in mind. 1000 kilogram per meter cube is equal to 1 gram per centimeter cube, right? So what kind of solid is this? This is a regular solid. So how will you find the density of such regular solid? You have to substitute it in the formula, right? D is equal to mass divided by volume. You can easily find the mass using the physical balance or digital balance. How will you find the volume? V is equal to A cube. You can substitute this in the formula and you can easily find out the density of such regular solid, right? But now answer my question. What kind of solid is this? This is irregular solid. You will be able to find the mass of this substance using the digital balance or physical balance, but how will you find the volume of such substance? Such solid? We have learned in our previous class also, that is in 7th standard, we have learned how to find the volume of irregular solid, right? So we need to measure both of these quantities and substitute in the formula to measure the density of irregular solid. We will see how. So in today's class, we are going to study how to determine the density of an irregular solid. First, we have to measure mass, right? How do we measure mass in our daily life? We use physical balance or digital balance. You may have noticed it in the grocery shop and when you are going for the medical checkup, right? So now we will see how the physical balance is working. This is the picture of the physical balance which we are using in the laboratories. This is somewhat similar to the common balance which we are using in the grocery shop, right? Yes, it is somewhat similar. But this physical balance is being enclosed in a glass case to avoid the external disturbances or external error caused to the measurement. Okay, so this is how the physical balance looks like. If you have visited the laboratory, you could have definitely observed this kind of balance. We will see how to use such kind of physical balance. We will see a demonstration and we will also learn how each part is working to find our mass. First of all, we will understand the basic principle of physical balance, so it will be easy for us to learn it. We will take this common balance as an example. How this works? We will add the substance in the one pan. Let's say it is left pan. When we are adding the substance in left pan, the left pan will be lowered because of its mass. Then what we have to do, what the shopkeeper will do when we are buying the things, he will add the standard weights to the right pan. When the total mass of the standard weights added is becoming equivalent to the amount of substance we added in the left pan, what happens? They get balanced. The pans get balanced. They don't get inclined in one position. They get balanced, right? Why? Because the amount of substance present in the left pan is becoming equal to the mass of the standard weights added in the right pan. That's why they get balanced, right? They are not inclining. The same principle is being utilized in the physical balance also. We will see how. How many pans are there in the physical balance? There are 2 pans, right? The 2 pans are suspended from the ends of the horizontal beam. Can you see in the top? There is one thing called beam. The 2 pans are suspended from the ends of the horizontal beam which rest on the knife edge. A long pointer is attached to the beam which can move over the scale. So, where is the long pointer? Here is the long pointer. This is the long pointer. And this is the scale. The long pointer is attached to the beam which can move over the scale. Usually when the beam balance, that is the physical balance, is not used, it actually rests on the central pillar supports. But when the balance is being used, the beam is raised using the handle and the beam rests on knife edge. The object to be weighed should be placed on the left pan and the suitable weights are added on the right pan until the pointer swings equally on both the sides. It can measure up to the masses of 1 kilogram with the accuracy of 10 milligram. If you want to take note of it, please take note.
Using a physical balance. Adjust the leveling screws such that the plumb line points vertically downward. Gently raise the central rod by turning the lever. If the pointer remains at 0 mark or oscillates equally on either side of the 0 mark, then the balance is fully adjusted. However, if the pointer swings more in one direction, then adjust the balancing screws such that it swings equally on either side of the 0 mark. Lower the central rod and place the article to be weighed in the left-hand side pan. Place standard weights in the right-hand side pan till the pointer oscillates equally about the 0 mark when the central rod is raised. Use forceps provided in the weight box. Record the mass placed in the right-hand side pan. This is equal to the mass of the body on the left-hand side pan.
Take note of the important points in the physical balance. So we have discussed all these points. And we have also discussed these points. What do we actually measure using the physical balance? Is it mass or weight? So to understand it properly, we have to understand the difference between mass and weight. usually represent the amount of matter present in our body using the term called weight. But it is not the right term to represent this. Why I am saying this? Because the amount of matter present in our body should be represented by the term called mass. So hereafter, as a science student, you should not do this mistake. So mass is defined as the amount of matter present in our body, present in any body. The SI unit of mass is kilogram. Then what is weight? The apple falls down because of the force of gravity, right? What is the connection between force of gravity and the weight? The weight of the body is the force with which the body is getting attracted by the gravity. The gravity varies in Earth, in Mars. It differs in each planet. Okay? The gravity differs in each planet, so the weight also differs in each planet. The SI unit of weight is what? It's Newton. Why? Because the SI unit of force is Newton. That's why the SI unit of weight is Newton. So what do we measure using the physical balance? We measure mass. Is there any other balance we can use to measure the mass? Yes, there is. It is called spring balance. We will see the basic principle of working of spring balance. Let's say I am giving you a spring and also a weight. You have to add the weight to the lower end of the spring and you have to hang it. What will happen? The spring will swing, right? Or we can say it will oscillate. Let's say when you add more weight to the hanger, what happens to the elongation of the spring? Will the elongation of the spring will be lowered or it will be much more higher? The elongation of the spring will be much more higher, right? When we are adding more weight to the hanger. Why? Because the elongation depends upon the mass of the object. So, if we want to find the mass of the object, it is possible for us just by measuring the displacement to which the spring swings. We can measure the mass of the object. What did I say? By measuring the displacement to which the spring swings, that can be used to find the mass of the object. We can easily measure the displacement using some scale. So this is the basic principle of spring balance. What do we actually measure using the spring balance? So the displacement of the pointer from the initial position to the final reading, that is 100, what do you think? What are the factors on which it depends? The object is being pulled by the gravity of the earth, right? So the displacement depends on gravity, and the displacement also depends on what? Mass of the object. So it also depends on mass of the object. So the displacement of the pointer in the spring balance depends upon the mass of the object and the gravity, that is the gravitational force of the earth. Now tell me, what do we measure using the spring balance? So we measure weight, because weight is equal to constant G into mass, right? So when we can measure the weight using the spring balance, we can calibrate, that is, we can calculate the mass using this formula, right? Weight of a body is proportional to its mass. So we can easily obtain the mass when we know the weight of a body. Spring balancers are available with various capacities: 100 gram, 500 gram and 50 kilogram. Let us see how to use a spring balance. First, the spring balance should be hanged in some stand. The upper end of the metal spring can be used to hang it. The lower end of the spring balance will have also some type of hanger to which we can add our weights, right? So this is how we should add our weights. Let's see how to take the measurements. We have to add our weights to the lower end of the spring balance, right? In this demonstration, we have taken the weights of 20 grams each. 5 weights of 20 grams each, okay? So, total weight including hook is 100 grams. Now we are going to check whether we are getting the correct answer. We are doing this as a checking process, right? So we are going to check whether we are getting the correct answers. So he is adding the weights into the hanger. 3, 4, 5, right? So this is 100 grams. He is going to hang it. Now observe the readings. What you can observe? The spring balance shows the reading of 100 grams and 1.0 newtons, right? So this is how we can find the weight and mass of the body using the spring balance. Let's take some notes on spring balance, shall we? Greater the weight, the more spring is stretched, and the greater is the distance through which the pointer moves. Weight is proportional to the mass of the object. So, when the spring balance gives the weight, we can easily find the mass using the relation weight is equal to mg, mass into gravity, right? Scale is graduated in such a way that it gives the mass of the body also. We have seen in the demonstration itself, right? The spring balance, the readings were mentioned in grams as well as in Newton. So we can also find the mass of the body as well as the weight of the body. To measure the mass, we have two balances. One is physical balance and another is spring balance. Now we have to learn how to measure the volume. We have already learned how to measure the volume of irregular solids by water displacement method. Do you know this famous scientist? Who he is? He is called Archimedes. Archimedes is the famous Greek mathematician, inventor and discoverer. What did he found? He found the water displacement method. Do you know how did he found the water displacement method? It's a very interesting story. One day when he was entering into the bathtub for bathing, he observed that the water is flowing out. Suddenly, a thought struck him. He discovered that his body is displacing the equal volume of water outside, right? His body is displacing equal volume of water. Suddenly he started to shout, "Eureka, Eureka!" What is the meaning of Eureka? Eureka means I have found it. What did he find? He found that he can find the volume of irregular object using this method called water displacement method. That is, by immersing the irregular object into the water, equal volume of water will be displaced. He can use that volume of water to find the volume of the irregular object. So that's how he found the water displacement method. This is an example for irregular solid. When the irregular solid is immersed in the water, what happens? It displaces the equal amount of water, right? So we can see the volume of the liquid displaced here. So what is the volume of stone here? You have to find out. Can you tell me? What we have to do? We have to find the initial reading and the final reading to get the volume of the stone, right? So the initial reading is what? The 600 is the initial reading. Initial reading is 600. Final reading is 800. So how can you find the volume of the stone? We have to subtract it. So 800 minus 600, we will get 200 milliliter. So this is the volume of the stone. This is how the volume of the stone should be calculated, right? Is there any other way to measure the volume of a irregular solid? Yes, there is. There is a can called Eureka can, which we can use to measure. Well, we are using the water displacement method. We need to do the calculation part, right? We need to find the initial volume and the final volume, and we have to subtract it. While using the Eureka can, you need not do any calculation part. How? This is Eureka can. You can see that it is also having spout, right? When we immerse the object into the water, what happens? The water level rises. Before immersing the object, what we have to do is we have to fill the water up to the level of the spout. Okay? So when we immerse the object into the water, the object displaces equal volume of water which can flow through the spout. The liquid can be collected through the measuring cylinder. So the measuring cylinder reading should be noted. The volume of liquid displaced is equal to the volume of the object, right? So this is how we can find the volume of object using the Eureka can. So when we know the mass and the volume, we can easily find out the density, right? By substituting in the formula. We will see how to join the class in the Google Classroom. First of all, you have to download the application from the Play Store. I think you all know how to download the application and enter into the application, right? So in the top corner, there will be a plus sign. You have to click the plus sign. When you click the plus sign, join class, create class, you will be given two options. You have to click the join class option. When you click the join class option, you will get this page. It says that ask your teacher for the class code, then enter it here, right? So you have to enter the class code IO5D7G3 for the physics. It's particularly for this class, okay? You have to enter it here, and when you click join, there will be a join button at the top of this page. It is not visible here. When you click the join, you will be entered into the physics classroom, and you can see the post there and assignments there, and you can easily submit your assignments. Let us see the assignment questions for this week on this topic. First question, density of aluminum is 2.7 gram per centimeter cube. Express it in kilogram per meter cube. Second question, calculate the density of solid from the following data. Mass of solid is equal to 70 gram. Initial volume of solid in a measuring cylinder is 20 milliliter. Final volume of water when the solid is immersed in the water is equal to 42 milliliter. So the first two questions are related to the problems, right? If you have understood the concept, it's very easy to answer these questions. Third and fourth. Third, explain the method of finding the volume of an irregular solid using Eureka can. Describe the method of finding the mass using the physical balance. So make sure you complete the assignments for this week. Take care, stay healthy. I will see you in the next class. Thank you, students.